Hi, my name is David Gilardi. I'm the Vice President of Sales Support and Education for Systems and Technology Group. And I'm here today to tell you a story about a data center. And it's a story that many of our customers can tell as well, because I'm going to talk about a set of problems that they have as well. We designed the data center 10 years ago to be a showcase for something that we call the design center. And what happened through the course of time is we added more mission to the center and we hit a wall. And the particular wall that we hit was around cooling. So I'm going to ask Roger Schmidt, who's a distinguished engineer in thermal engineering, and Highland Potter, who's an executive IT specialist, to join me and tell the story of how we solved the problem, and in the process we worked smarter.
The first step is really determine where the problems areas are in the data center. So we used a tool that was developed by the research division a couple years ago called MMT, Mobile Measurement Technology Tool. And what it does, it basically profiles the data center from a temperature standpoint. Each level of the tool has temperature probes. They have over 100 plus temperature probes on this tool. So as we roll it around, we get temperatures at each tile placement throughout the data center, and from that temperature profile that we create at post-processing, we can determine where the problems are in the data center. We took the results of the MMT study and then looked at the data center and tried to determine where the problem areas were, where the high heat loads were, where the over temperature problems were, and then took those results and then built on that with using another tool called CFD, Computational Fluid Dynamics tool. So we ran about 40 odd runs of different layouts to try to optimize the data center from a ventilation standpoint, from a heat load standpoint. And from those results, we had an optimized data center, the most efficient, using the best practices that we could deploy in this data center.
Once we started analyzing the floor, we realized that by laying it out as a showroom, we had inadvertently created a lot of bad practices. The rows of machines in the front were actually exhausting heat into perforated tiles in the back, where additional machines would then try to use that for cooling. In addition, we had done poor cable management as well as other things in the raised floor itself. The racks were not laid out correctly. We had gaps in the racks in between them, as well as in between the machines in the racks. What this did was it allowed for the air to intermix from the front to the back, and this is what gave us a room that was extremely hot. Once we started looking into the floor itself, underneath the raised floor, the cables, we had run the cables across the cold air coming from the cooling unit in the room, so we were actually blocking the air that we needed to get to the front of the machines. After identifying the issues in the room and running through the modeling, we realized we needed to break the room up into two specific zones, an air-cooled zone and a water-cooled zone. The water-cooled zone is using cooling distribution units as well as rear door heat exchangers to take the heat away from the racks. In the air-cooled zone, we've identified exactly where the perforated tiles need to be to get the cold air directly to the machines that need it, as well as the creation of a true hot and cold aisle. While laying out the racks, we determined that we needed to load them from the bottom to the top, eliminating any air gaps either within the rack or in between racks to make sure that the air itself is not being contaminated or mixed between both the front and the back areas within the racks. We also looked at the cable management. We identified that we needed to use cable trays where possible and to run the cables in the hot aisles, as well as in running the cables up into the machines, we need to take advantage of and use pillows or brushes to eliminate any loss of cold air on the back of the machines.
Once we update the data center with the proper hardware, placement of the perf tiles, placement of the water-cooled hardware, we then go back in and verify everything, make sure it meets all our specifications. So we go back in and rerun the MMT tool, the mobile measurement tool, take data throughout the data center, create the 3D profile of that, check all our temperatures, look at the ventilation, and make sure we're all in specs. And based on that study, everything was in spec, we were optimized, we were fully utilized on the computer room air conditioning unit, and we didn't have any alarms that were going off.
One of the things that we wanted to do in making changes to the room was to understand exactly how all the equipment was running. The first thing we did was install thermal sensors that would gather for us both the temperature, barometric pressure, and humidity of various areas within the room. We also feed that directly into Director AEM along with the energy consumption, either taking the metrics directly from the servers within the room or using power distribution units, commonly referred to as PDU pluses. In addition, we're using Tivoli products like NetCool Omnibus to gather events and surfacing all of this up into a Tivoli Enterprise portal, which is part of the ITM product suite. This dashboard gives us the latest information of what's happening in the room so we can make adjustments where necessary and plan for future expansion and use of additional hardware.
As you can see, we solved our problems. We took the underlying symptoms and we removed them. We used advanced technologies to monitor the environment. We understand what's happening with power. We understand what's happening with thermal. We've created a smarter, greener, more energy efficient data center, and we're positioned for growth. We can add more technology to the room without any changes.